I'm just quickly going to demonstrate that. So let me remove a file. And if I take a look into the directory at the most recent version state of the history, there actually is no chinstripe file. Inputs, images, there's one file, but there's the other one that I deleted. It's gone. But as you very correctly said, this is just the most recent state in my history. So one thing that I can do is I can, for example, say git checkout, and then I'm going to go one commit back. And if I repeat the list command, then actually the file is still there, and it also has its content here. There's still this penguin, and removing it and even saving this remover has done nothing to actually free my data set of this file. Even though I can now go back to the most recent state, so you've seen me time travel a little bit. Now I'm back into the most recent revision where this file is gone. I can still say, oh man, here, this is what I've been messing up. So I can say git revert. You can see now I haven't included the no edit flag, so it will ask me which commit to associate with it. I do not recommend to get in this state because it's Vim, which is a little bit of a weird editor if you haven't used to it. If you ever end up in this thing, Vim, the way to save a file, to save this and get out of this, is by doing :WQ and then hitting enter. It's an editor that requires a little bit of knowledge, but sorry. But now that I've reverted this commit where I've removed stuff, it's come back to life. So that's problematic in case I have a data set that contains, 500 gigabytes of files, and I actually don't have that much space, and I want to get rid of the files, and I maybe want to remove them permanently even. So drop and remove are the files that will make it possible to delete file content or temporarily delete file content from your disk, or permanently delete repositories from your file system. And in order to practice this, you can turn to the code that I've shared here, and I think that's the wrong one. Sorry, that's branching. Actually, it should be this one. Episode removing datasets and files. Shared the wrong link. Oh, Michał already did it. So in order to practice this, we're going to just clone a dataset from GitHub that has a little bit of content, that just to practice. Importantly, do this outside of the dataset that you've created. So don't clone it inside of another dataset. We'll do that tomorrow. But change directories into, for example, your home directory. And clone this dataset. So this dataset just contains a collection of PDFs of a couple of really cool books. And let's get some file content from this dataset. It's not much, it would be super fast. And then let's drop the file content to free up the disk space again. That was really easy. Now, the reason that this was easy is that some built-in security checks passed for DataLad. So whenever you clone a dataset from GitHub or from a different place and you are able to get the files, then you will also be able to drop them right away to free up disk space and to get rid of file content. What you can conceptualize drop as is the antagonist command to get. So drop tries to behave in a way that whatever get does can be undone by drop. The default safety check that I mentioned, though, is that DataLad ensures that get can actually reobtain the file that drop has just removed. So if I run git-annex where is on this file here, then there is a remote registered location, and if I get it again, then there will be 2 locations. One is on this machine, one is on the web, and in those cases it's safe to drop it. What drop also does, and this is only going to be part of the session tomorrow, but I'm just including it here, it also does something that's called uninstall subdatasets. So if you have a dataset that has loads of subdatasets, the Human Connectome project dataset is an example of that, then get is able to get subdatasets to individual linked datasets, and drop is able to drop those or uninstall those datasets. And just like get leaves a trace, like the file name back in your dataset that you can then act upon and get, when you drop a subdataset, there still is a name of the dataset, and if you run get on it, then you will be able to reinstall it. So drop tries to be this really safe command that just, you know, frees up your disk space in the case where you can get the data back. Let's take a look into removing datasets, and also first in the easy way, and that is done with DataLad remove. So in order to remove a dataset, that is, oh, I think I've seen a hand. Yes.
Yeah, I was just wondering, so normally, I mean, if I would delete something and then I look at git status, it says it's deleted, but I would have to do a commit to actually delete it, right?
Yes.
And so does this run the commit in the background, or
DataLad save?
Pardon?
Drop you mean?
Yeah, or I mean, does it have anything to do with the commit in the background?
This is a really good question. It doesn't create any commit at all. It will not leave a trace in your Git revision history, but it's also not something that has the same flavor as an RM and then save as we did at 5 minutes ago. Because it is a command that you run on annexed contents to free up the disk space. So just dropping the file content locally or reobtaining the file content locally, it will not change anything in the revision history of your dataset because it will not have actually modified any of the contents of your file. It will just alter the availability information. It's just that there's an internal record, and that will be amended with, okay, the file is here now, or the file is not here now anymore. But in this typical Git revision history, you will not see that come up. It's actually something that is still stored on a branch, but that would be a little deep dive.
Okay, thank you.
Yeah, but thanks a lot for the question. So in order to remove a dataset, you run a command that's called DataLad remove, and that's a command that you need to run outside of datasets, which is very rare. Usually you run DataLad commands inside of datasets, and they would complain if you don't, if you're not in a dataset. So what you do is you have this little -d flag. This is a very common flag to use. It needs to point to the dataset that you want to operate on in the case of remove. So DataLad-d machine learning books will tell DataLad that it should remove this precise dataset. It's very useful to include it just to be super sure which dataset shall be removed. And if I run this, then it will uninstall it, drop it, and it will actually be gone without any trace. So you can conceptualize clone as the antagonist, remove as the antagonist command to clone. So where clone installs a dataset from thin air that wasn't on your system before, remove makes it vanish from your system and creates the thin air again, basically. the default safety checks that remove has are a little bit interesting when you first run into them. What remove does is it makes sure that you could be able to reclone the dataset in the state that you have removed it. So what this will check for is what is called a sibling, which is a remote location where this dataset can be cloned from, such as its original location from GitHub. And if it cannot find this remote location where you can theoretically reclone it from, or if you have additional commits in your dataset that are not available on the place where you cloned it from, then that safety check will fail and it will say, hey, you're about to potentially lose modifications that you have done here. Do you really want to continue? And I'm going to show you how it looks like when those safety checks fail for drop and remove. And for this, you can join me in creating a new local dataset. That's a dataset that we don't clone. It's not available from anywhere. And inside of this local dataset, let's just create any kind of file, blah, blah, blah. I'm just echoing file contents into a text file because this is a dataset that I have created without any modification, even though this is a text file. Running DataLad save will annex this file. So now I have an annexed local file. And if I run git-annex where is on this file, then it will only be available here and from no other location. And if I now were to run DataLad drop to free local disk space from the contents of this file, then DataLad will say, oh no, I'm not going to do this. Are you really sure that you want to do this? So it says unsafe, could only verify the existence of no out of one necessary copies of that file. That's a configuration. You can change that. You can make sure that, for example, you have 2 copies of every file just to be extra sure. And then it says if you want to override the security check and potentially lose data, because I don't know any place where I could retrieve this for you, then you can use a parameter that is called reckless with a mode that indicates which safety check should be overwritten. And in this case, it's the availability safety check. So what I can do in order to really enforce data loss basically here, and I mean it's not that there are really valuable use cases, like you have created stuff that you really don't need anymore, that's plainly wrong, or just past versions of files, then drop the file content. That's completely cool, but there is this built-in security check that makes sure that there's no data loss. So it's a lot of text to write. I always mistype, but when you run DataLad drop with -- reckless availability, you will basically disable the safety check. So it will just be really fast. It will not try to check any remote location. It will just drop that file. But the content, so you can see this is kind of a dangerous looking markup here that the shell applies. This means there is no content here. I'm just a poor broken symlink. I'm just a poor file name with no content associated to it. And at this point, there's no way to get it back. A different use case, for example, is when you drop stuff and there is a remote registered location, but it's not available. So if you do this on your local computer with the books, for example, and then cut off your internet connection, then it will not be able to perform the safety check so it probes the remote location on whether it actually still has the file and whether that file has the right identity. Or if you have a backup on your USB stick, but your USB stick is not plugged in, the dataset will have a record of, hey, this file should be available from the USB stick, but it can't reach the USB stick. So in that cases, those checks would also obviously fail. And then you can also just override them with the reckless availability check. One thing that you should be mindful of is that drop will only drop the most recent version. So only the file content that your most recent or that the dataset state points to. If you have a file that has been frequently modified and you want to remove all of the past versions that exists of this file from your dataset history, then there's a convenience command that is called git-annex unused that will go through your history of files, and it will check if there are any past versions of files that are simply not referenced anymore. So if you remove a file, if you drop its content, but there are contents from the previous commit, then git-annex unused will identify, hey, here's stuff that you indicated in one version you would not need anymore. Shall I drop the other stuff too? And then you can instruct it to drop them as well. But again, it's something that will cause data loss in case you are dropping stuff that's not locally that's not available anywhere else. As for remove, if I were to DataLad remove this data set, what DataLad will perform is again an availability check on whether this dataset can be cloned from anywhere else. And there is no location where I have cloned this from, no local path, no remote path, no URL, no GitHub repository. And the error message that you will see in this case is to be dropped datasets has revisions that are not available at any known sibling, so at any other linked dataset. And then it advises you to either DataLad push, that is publish the changes to a remote location so that there's a different copy of the dataset that still has all of your modifications secure and version controlled, and you can reclone it if you need to. Or ignore this check also via DataLad, via reckless availability. It also includes a little indication of what is the revision that is not available from anywhere else. This is not so useful in the case of, hey, I have a local dataset, I'm just going to remove it. But let's say you have a dataset and you remove it, but it actually contains some new additions on, for example, a different development streak. Then DataLad will say, hey, you did do these kinds of changes in that location or in this timeline here of your dataset. Are you really sure you would want to permanently remove them and let's say not push them or propose them to an upstream repository? So just as with drop, reckless availability to this command invocation overrides the security check and lets you uninstall datasets that you probably would not be able to clone again. Now, the one thing that happens with DataLad datasets when you remove them wrong is you will get a number of colorful permission denied errors. And I'm going to show you how to remove a dataset in the wrong way, because it sometimes just happens by accident or by someone who has never worked with a DataLad dataset. So for this, I'm just quickly going to create this local dataset again. And I'm also going to add a file into it so that I can show you what is shown on the slide, because this only happens in datasets where you have annexed content that is locally present, but this is often the case with datasets. So we again have a local dataset with annexed files, and if I now were to use the standard Unix way of removing directories with an RMRF of this local dataset, what you will see is stuff like that. So for every annexed file that is locally present, it will have a pointer into the internally version controlled file that is not writable, and it will leave this this zombie directory in your working directory. It kind of looks empty, but it actually isn't empty. what is it, ls. There is still the Git repository, but the Git repository has been completely crippled. It has been stripped of everything but the right protected files. It's a butchered up version controlled directory. There's no way to restore this. It is completely broken. You can't get a version history from it, but it has this weird gibberish thing here that you will not be able to RMRF in any way. So what happens, what you need to do in case you ever happen to RMRF a dataset accidentally is, and that's for Unix. Windows will not have that problem, so Windows users can just relax. But on Unix, you have to what is called chmod it, that changes the file mode bits that indicate whether or not the file has write permissions or not. So the command on a Unix terminal is chmod plus W. That means add write permissions plus write permissions, and then minus -r to apply this operation recursively throughout all contents of a directory, and then local dataset. So make the complete dataset or the complete directory, and all it includes every subdirectory writable. And then you can actually RMRF it, and then you have cleaned up the mess.